Hi class, today's lesson is lesson 4-5. It's on equivalent fractions. Our purpose today is to write equivalent fractions. Let's take a look at some terms that we need to define at the back of our composition books. First term is equivalent fractions. Equivalent fractions are fractions representing the same value. If we look down here at these three circles, and I want you to go ahead and draw these three circles, you'll see that the first circle is divided directly into half, and the pink shading indicates half of the circle. Well, in the next drawing, the same area has been shaded in pink, but this time it's divided into fourths. So how many fourths are there in 1/2? Well, there are 2 fourths. So 1/2 is equivalent to 2 fourths, the same shaded area. Again, we see the same shaded area in the third circle. This time the entire circle has been divided into eighths. There are 8 parts to this circle, and 4 of those eighths are shaded in pink. So 1/2 is equivalent to 2 fourths is equivalent to 4 eighths. These are equivalent fractions. Simplest form. Simplest form is an equivalent fraction written so that the greatest common factor of the numerator-denominator is 1. We're going back to this diagram once again. When we look at 4 eighths, the greatest common factor of 4 and 8 is actually 4. For those two, for the numerator-denominator. So that's not in simplest form. The greatest common factor here, I can readily see 2 goes into both of them. In fact, 2 is the greatest common factor, and so that's not written in simplest form. I get to here and I find that the only factor that is common to both 1 and 2 of the numerator-denominator is 1. This is written in simplest form. First example, we have to find 2 equivalent fractions for 6 eighths. What we're going to go ahead and do is I'm going to drag in an identical diagram of the initial diagram and show you that we can look at it just slightly differently. Here we have 6 eighths, 8 total parts, 6 shaded. Same thing here. But this time, I'm going to look at this as divided into fourths. There's 1 fourth, 2 fourths, 3 fourths, 4 fourths. Equal sizes, but there's 3 of the 4 sections are shaded in. So 6 eighths is the same thing as 3 fourths. And actually what has happened here, this is in simplest form if we wanted to be specific, because the greatest common factor of both the numerator and denominator is 1. Let's go ahead and take a look at another equivalent fraction. Know that there's an infinite number of equivalent fractions that we could make. We just don't have the time to find them all. What I'm going to do is I'm going to divide this top section on this top row in half, just like that, and I'm going to divide this bottom row in half, just like that. Now what I have is I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I actually have 16 parts here, so 16 is going to be my denominator. How many sixteenths are shaded in? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sixteenths shaded in. The shaded in area of each of these 3 figures is exactly the same. Therefore, 6 eighths equals 3 fourths equals 12 sixteenths. Moving to multiplying and dividing to find equivalent fractions. Here it asks us to find the missing number that makes the fractions equivalent. Here we have a diagram that's 2/3. And we're translating that into 18ths. And you can see that this is 6 rows of 3, which is 18 parts or 18 pieces. Notice that the shaded in area, the purple area, is exactly the same. It's just been divided up differently. what did we do in order to go from a denominator of 3 to a denominator of 18? Well, we actually multiplied by 6. And what we do to the bottom, we need to do to the top, just like in algebra. What we do to one side, we do to the other side. Here, what we do to the numerator, we do to the denominator. So 3 times 6 is 18, so we have 18 parts. 2 times 6 is 12. And look, let's verify what we have here. We should have 12 shaded in areas. 1, 2, 3, 4, 5, 6, and another 6 is 12. So this works. What are we actually doing? Well, when we multiply 2/3 times 6, what is 6 over 6? What is 6 divided by 6? Well, 6 divided by 6 is just a 1. So here we're multiplying 2/3 times 1, which is the same as 2/3. What this is saying is when I multiply by the numerator and denominator that are the same, I'm not changing the value because it's just like multiplying by 1. Okay? Let's go over to 70 over 100 equals 7 parts over what? Well, here we did the opposite operation. Here we divided 70 by 10. So we need to do the same to the bottom, which is divide by 10. 100 divided by 10 is 10. So 7/10 is equivalent to 71/100. Example 3, this is where we're going to look at making fractions into simplest form. Here we're going to take 18/24 and we're going to carve it down into its simplest form. 18/24. First method we're going to use is the greatest common factor. So I look at these, and certainly you can list it out or use a prime factorization tree, but I can pretty much look at this and see that 6 goes into both 18 and 24, and that's going to be the biggest common factor that they have. So I'm going to go ahead and divide top and the bottom by 6, and what I get is 18 divided by 6 is 3. 24 divided by 6 is 4. I get 3/4. Now, what's the greatest common factor of the numerator and denominator here? Well, the greatest common factor is 1, because there's no other factors they have in common. Therefore, this is the simplest form. Now we can work the same problem using prime factorization. I can go ahead and make 18 over 24 equivalent to, well, I know 2 times 9 is 18, and 9 can be further broken down into 3 times 3. There's my prime factorization for 18. And 24 is similar. I get 2 times 12. I'm doing this mentally, of course. You can do this on a tree if you desire, or with the ladder method, but I'm doing it mentally for this purpose. 2 times 12, and 12 can be further broken down by 2 times 6, and 6 can further be broken down by 2 times 3. And then we have all the factors here. We're going to have to double check. 2 times 2 is 4, times 2 is 8, times 3 is 24. So I've got the right prime factorization. Now I'm going to look at what they have in common. And when I look at what they have in common, they have these 2's in common. They have these 3's in common. And I'm going to knock those out, because 2 divided by 2 is 1. 3 divided by 3 is 1. And so that leaves simply 3 over 2 times 2, which is 3/4. So you can come to simplest form using prime factorization here. Looking at this last example, we're looking at 8/9, writing this in simplest form. I think about factors. What factors do I have of 8? Well, there's 1, certainly it goes into both. 2 goes into 8 but not into 9. How about 4? 4 goes into 8 but not into 9. 8 goes into 8 but not into 9. I've listed all the factors of 8 that I could. It looks like the greatest common factor here is 1. That's what they have in common. Therefore, this is already in simplest form. Now it's your turn. You've got actually five problems here. First problem, find two equivalent fractions to 4/6. The others are find the missing numbers that make the fraction equivalent. Remember, I'll give you a start here. How do we get from 2 to 10? Well, we multiply here, and you're going to have to take a look at this one to get that determination. Write each fraction in simplest form. Again, there are two methods that you could use to get it down to its basic form, where the greatest common factor of the numerator and denominator is just 1. Go ahead and attempt those, and we'll see you in class.